Okay, let me once again continue with quick review of soil mechanics, that is part 4 now, and under this I will try to highlight certain points on shear strength aspect of the soil. Again, as I have told you that these are the things will be used again and again in the foundation engineering competition. And so, let me take few slides. And what is shear strength actually? Why it is important? Actually, in many soil mechanics problem, the shear strength of the soil emerges as one of the most important characteristics, and those problems can be grouped like this. You can see number of them when you will study stability of slopes or carts, embankments, earth dams, hill slopes or any other similar structure. That earthen structure, when we will try to do stability analysis, the shear strength become a very important. Then ultimate bearing capacity of soil, that means when you put a foundation on the soil, then the soil will foundation will give some pressure to the soil, and soil will have a capacity, and beyond that if you put, then foundation is going to fail. So, that computation of ultimate bearing capacity also you need shear strength concept. Then lateral pressure against retaining wall, there also you need sitting or bracing, friction develops by piles. So, I have mentioned that there are two types of foundation, one is shallow foundation and deep foundation. So, pile is one of the deep foundation type, and there while calculating their capacity and other thing, there also you need very much this shear strength concept. So, with this then, but shear strength where from it comes? Shear strength actually of the soil may be attributed to three basic components. You can see there it is listed, that frictional resistance to sliding between the solid particles. When the soils are granular particles, it can be fine, it can be coarse. Those granular particles when moves from each other, then there will be resistance when sliding between solid particle, one particles sliding over another, then there will be resistance. And cohesion and adhesion between the soil particle, that is another source of resistance, shear resistance, and interlocking and bridging of soil particles to resist deformation. So, when we apply load, then you will try to reform, and then to resist the deform, that type of interlocking and bridging effect also will contribute some amount of shear strength. But it is very difficult to differentiate these two effects or separate these two components of these components of shear strength of the soil. That means, though I have mentioned there are three components, grossly this can be attributed, but very difficult to find out that this is the because of this and this is because of this or this is because of that. But we have some mechanism we will discuss later on to estimate that. Oh, sorry. And you can see that whatever things I have mentioned, that frictional, then cohesion, adhesion and bridging or interlocking effect, they again depends on many are influenced by many things, and they are listed here. Change in moisture content, as I have told you, the moisture content in the soil is very important. A dry condition soil will behave something, and if it is a totally wet, then it will behave differently. So, that is why moisture content is another important, and it will influence the shear strength of the pore pressure. The pore pressure, that means, if you consider a soil mass at a great depth and water table is close to surface, so whatever pore pressure is there, and if I another side, if we consider the water table is quite deep, in that case pore pressure will be comparatively less. So, that is also there. So, that pore pressure, if the pore pressure is more, then effective stress ultimately will be less, and if pore pressure is less, then effective stress will be more, and that is actually that is the way it influence the shear strength. The structural disturbance, actually there will be orientation of particles, etc. Then fluctuation in the groundwater table. So, as I have mentioned that if water table originally was here, if it goes up, pore pressure will increase and effective pressure will decrease, and water table goes down, that means pore pressure will decrease and effective stress will increase. And then the stress history, that means some soil will be stressed before and some soil may be deposited newly. So, because of that the shear resisting capacity will be different. Then perhaps chemical action and environmental condition also another important factor which also can change the influence the effective stress. But we will not be able to quantify them, but we know they are they all influence the friction resistance, shear resistance of the soil. Now, grossly, as I have told that we cannot quantify that three quantity we have mentioned, but finally, we have to do, and there are theory developed, and that shear strength of the soil finally defined or given by an equation by there is a two component, one is cohesion component and another is frictional component, and that the cohesion component is constant for the soil, whereas frictional component is variable. That means, it depends on how much normal stress acting on it, the frictional resistance depend on it. So, that means, if I consider a soil at one point here and another point here, this point is shallow depth and this point is greater depth. That means, normal stress acting at this point is higher than this point. As a result, the frictional resistance will be at this point will be more than this point. So, that is the sigma times tan phi is the frictional resistance. That means, sigma how it is varying, because when you go deeper and deeper, sigma of the soil is increasing. As a result, the frictional resistance when you will go deeper and deeper will be increasing. So, this is the simplified, very simplified shear strength equation. Shear strength of the soil is C plus sigma tan phi, and this is though called cohesion component and this is frictional component, but sigma we can calculate as I have mentioned previously the way we have mentioned, and this is another component called tan phi, and this tan phi the phi is actually frictional coefficient of friction, internal friction, and C is the cohesion of the soil. That means, the C and phi they are the two parameter. If I collect a soil at this point, then I have to find out C and phi of that depth. So, that I can use this equation and find out the shear strength at that point. So, tau f is the shear strength at failure, that is this equation is considered as failure's condition. C is the cohesion and sigma is the normal stress at that depth considered, and phi is the angle of shearing resistance or angle of internal friction. So, these two C and phi, this C and phi actually basically the shear strength parameter of the soil, and that to be determined for assessing the shear strength. So, this is actually written in terms of total stress, but as we have mentioned that most of the time in fact, in practical we do always in terms of effective stress, and if you write the shear strength equation in terms of effective stress, the equation will be almost same, only the C will be by C prime and sigma dash will be replaced by sigma dash or sigma prime, and phi will be replaced by phi prime. That means, this is the effective friction angle, effective cohesion, and this is the effective stress. When you consider effective stress concept, then this is the equation. They are actually effective cohesion you have to use, effective normal stress you have to take, and effective friction angle. Okay. So, that means, if I have a ground here and water table is here, and if I consider water table is here, then if I want to find out at this point shear strength, I will find out what is the C value, what is the phi value, both in this form, and then I will find out at this point what is the sigma dash, then I will put in this equation to get the effective shear strength. And this is of course, in soil mechanics is a very basic actually how the failure envelope of the soil looks like. There can be failure envelope generally will be having an intercept here, and there will be tangential to that way we can draw the Mohr circle, and then it will be if we draw a tangent to the Mohr circle, then there will be intercept here and and your this is the way, and Mohr circle actually when you will conduct the test, there will be sigma 1 will be sigma 3 will be applied and sigma 1 will be at failure to be considered calculated, and based on sigma 1 and sigma 3 we can draw the envelope, and then like that if I know the failure envelope, and then I can draw tangent to that, and then we have the sigma 1, sigma 3 and C and phi. This is the failure envelope, that means the angle is the phi, and your this intercept is C, and if I consider this triangle, and from this actually sin phi can be expressed by d c by O dash c, and then simplifying this I can reach this equation, and finally, I can get sigma 1 minus sigma 3 equal to this form, and k can be substituted by c cot phi, and then sigma 1 sigma 3 will be a equation we can get by this, that means sigma 1 minus sigma 3 will be equal to 2 c cos phi plus sigma 1 plus sigma 3 sin phi. That means, this is the relationship between principal stresses and phi and c. That means, two unknown actually we have c and phi, and then if you carry out test with two values of sigma 1 and sigma 3, and then I can form two equations. Suppose I conducted a test with sigma 1 and sigma 3, sigma 1 1 and sigma 3 1, and sigma similarly sigma 1 2 and sigma 3 2. Then based on this I can set two equations in terms of unknown c and phi, and then finally by solving them I can find out the c and phi. This is the equation, well known equation, some relationship between phi and cohesion and the major and minor principal stresses, and this will be frequently used for finding out c and phi if you know the normal principal stresses. And this is actually in terms of total stress, but if you same thing if you write in terms of effective stress, the equation will be same, only sigma 1 will be replaced by sigma 1 dash, sigma 3 will be replaced by sigma 3 dash, and like that, and phi will be replaced by phi dash. Now, this as I have mentioned that c and phi are the shear strength parameter, and this you have to find out, and there are number of methods to find out. There is a direct shear test, there is a triaxial test, there is unconfined compression test, and there is a Wien shear test. And direct shear test actually we make in a box, actually it can be divided into two halves. In between inside that we make a soil sample, and the two parts of the box we try to slide by force. So, that means in a predefined failure plane we try to fail the soil, and based on that we at a particular normal stress we apply, and then we put horizontal stress, and we find out what is the failure load, and from there we can find out what is the shear stress and what is the normal stress, and your sigma equal to or tan phi equal to tau by sigma. So, that means I will apply horizontal force, and that horizontal force from the horizontal force at failure divided by the cross sectional area give you the shear stress, and whatever load you have applied, that load divided by cross sectional area of the sample will give you sigma, and then tau phi will be nothing but tau by sigma. So, that is the direct shear test apparatus we use, and that is the way we calculate. By of course, we can do by one test we can find out phi, but since the test may not be that accurate and there may be some experimental problem, we try to do 3-4 tests, and finally, if we plot tau versus sigma like this, points are coming like this, and finally, you join them, and then after joining this you find out the slope of this. Suppose this is phi, that is the friction angle of the soil, and most of the time shear strength direct shear test is carried out for a dry sand, and so dry sand will have only phi, and that can be easily obtained by this way. Similarly, there is a triaxial test. Triaxial test means actually here all three dimension actually pressure will be applied, and this is actually actual field condition can be simulated in the test, and so there is a apparatus where we can put the sample first and then we can apply a confining pressure, and then applying a normal pressure we can increase the normal pressure till the sample fails, and based on that we can find out two principal stresses at failure, and number of tests we can carry out, and finally, you can draw number of more circle based on that, and drawing the common tangent to those more envelope, we can find out the soil parameter of the soil. So, typically this the triaxial apparatus is like that. You can see here this is the soil sample, and this will be kept in a chamber, and this in this chamber, and then you can apply through water, you can put all round pressure here, and then when water pressure is applied, then all valve can be closed, and then you can apply normal load through this, where by which you can apply some normal stress, and you can go up to the failure. And of course, this is a very generalized type of test apparatus. We can different condition you can you can simulate, undrained condition you can test, drained condition you can test, and there can be also consolidated or unconsolidated also can test. So, different types of tests can be carried out, and by and large the procedure is you have to first apply a all round pressure, and then under that pressure you have to apply additional pressure to fill the soil sample. So, that is the by and large a brief schematic of the triaxial apparatus. And this is the as I have mentioned, you can see from this procedure you can see during test, when you apply normal stress, the at failure, suppose this is sigma 1 and sigma 3 you have applied, but this will be consist of two parts. Actually, initially you have applied sigma 3 all direction, and then later on you have applied sigma 1 minus sigma 3. This is called deviator stress or principal stress difference. Sigma 1 minus whatever you are applying, that is actually sigma 1 minus sigma 3. So, these two together actually we apply first this and then this, and these two together result this, and this under this condition we achieve the failure. And like that different sigma value we can, sigma 3 value we can apply. So, suppose sigma 3 is 200, then stress and curve we can stress versus deviator stress, we can strain versus deviator stress we can plot. Similarly, applying sigma 3 400, another graph you can plot, sigma 3 actually 600, another plot you can get, and from here we can find out the sigma 1 and sigma 3 at failure, that the principles that is called delta sigma at failure we can find out, and from there, since delta sigma f is known, that is nothing but sigma 1 minus sigma 3, and sigma 3 is known. So, sigma 1 can be calculated, sigma 1 will be delta sigma f plus sigma 3. So, that means sigma 1 sigma 3 at the beginning known, and then you have got sigma 1 at failure. So, that means sigma 1 and sigma 3 you get, suppose first set of test sigma 1 and this is sigma 3, second set of test sigma 1 and this is sigma 3, third set of test this is sigma 1 and sigma 3, we get all three circle, and then you know that the same soil, that means failure envelope will be same. So, that means your envelope will be tangential to the all the three circle, but during test you hardly get this similar this circle, that it will be tangent will be common, it will be common tangent will be there. So, what we will do by approximately you have to draw the common tangent, it may not be tangent really, but to get a best fit result you have to draw a common tangent by eye estimation, and after doing that from this slope we can get the phi, and from this intercept you can get the value of C. So, this is the triaxial test procedure by which we can get the soil parameter C and phi, and again different condition as I have mentioned, that drain condition, undrained condition. Of course, drain condition parameter is more effective, and but it takes long time. Sometime undrained condition with pore pressure measurement we can do also, So, those are the things actually the part of soil mechanics in details we have discussed, but I have given you that some highlight about the triaxial test. I will not go beyond that, and during the test actually soil may fail like this, that is called shear failure. The soil may continuously shorten, that is, and then this is called bulging, and it will be shorting and elongating in the lateral direction, that is called bulging, and sometimes simultaneously bulging and shear may take place, and that is the another type of failure. Okay. And then there is another test, actually unconfined compression test. Unconfined compression test also almost similar, only difference is that sample will be prepared the same, dimensions are same, only thing is there will be all round pressure will not be there. Only after fixing the sample we will put directly normal stress, and based on that normal stress soil will fail, and this type of test will be carried out for only carrying out the undrained test of saturated soil. So, quickly if I want to find out undrained test of undrained strength of the saturated soil, we can carry out by unconfined compression test. And there is another test that I have listed, that is vane shear test. That is actually some of the soil, as I have mentioned that whatever direct shear test or triaxial test or unconfined compression test, there actually you have to collect the sample, prepare the sample and get the test done in the laboratory. And there are some soil where actually if the so sensitive that you cannot sample it, or if you sample it during sampling procedure it get disturbed, and as a result during laboratory test whatever result will be getting, that result will not be truly representative. So, as a result those type of soil sometime we carry out some in situ test, and that is the one vane shear test. One such in situ test, there are two vanes put perpendicular to each other, rectangular vanes perpendicular to each other and connected to a rod, and that vane will be pushed inside the soil, and then the vane will be rotated by torque. And when actually the initially because of the resistance of the soil, it will take some amount of torque, but when the applied torque will be becoming more than the resisting torque of the soil, then soil will indicate the failure, and based on that we can find out the shear strength parameter of the soil. So, that is the one I can show you in the next slide. You can see this, the vane actually looks like this. There are two rectangular part, you can see this is one rectangular part, this one, and this is another rectangular part, and they have definite dimension with this rod, and in this rod torque will be applied. And then when you do this, the shear resistance will be from the base and at the vertical cylindrical surface, two places, and also at the top. Sometime if it is not deep enough, resistance at the top will be ignored, and if suppose the resistance from here and whatever resistance is there like this different resisting stress is there, if I take moment at this point, that will get the resisting torque around the shaft from the soil, and then again from the vertical surface there will be some stress as acting resisting stress, that if you again take the moment with respect to center, that is another resisting torque. These two resisting torque, if you compared with the resisting torque applied through this and then simplified, then you will get this equation, that T equal to pi Cu d square h by 2 plus d cube by 12. There actually Cu is the undrained strength of the undrained shear strength of the soil of the soft soil, and d and h actually dimension of the vane. So, by this way quickly also you can find out the shear strength of the soil for sensitive soil, that is actually very important. Sometimes we ask question that where the vane shear test is suitable and etc., and sometime how to find actually, then that mechanism also you have to explain. So, this is again we have is a part of soil mechanics, but determination of shear strength. So, one second, because of that I have again put it together quickly. With this by and large I have completed shear strength aspect. Next aspect will be compressibility. I will take one more session on this quick review of soil mechanics, That is all today. Thank you.